gang, here we are, we're in Chapter 8, User Interface Design. There are entire courses that's all they deal with is interface design. Both from an artistic standpoint, as well as understanding the individual's potential disabilities involved and legal aspects of it. So, we talk about systems design. We need to build something that is effective, reliable, maintainable, easy to use. The users understand how to interact with it, what's expected of them, and the system does what it's supposed to do when users interact with it. We avoid hardware problems, we avoid human mistakes because we design this so effectively that we don't allow them to enter bad data or information in a way that should not be entered. So, users can design their own output. System designers are more aware of user needs and desires. So these conversations that we've had with the people that are going to be using the systems, we can have mock-ups or prototypes that we show them and say, hey, what do you think of this? And at the same time, we have somebody that's never used the system and present that same thing to them and say, what do you think of this? And we want feedback from not just people with experience, but those with no experience to make that ease of use more better, more comfortable. Now, the user interface has evolved over time. Now we deal with what we call a GUI or graphical user interface. We focus on usability, and like I said, there's entire courses. I've taken graduate courses on human-computer interaction. So, the models and the prototypes that we come up with will help us focus on the usability, and we document everything. We invite users to give us some input, give us feedback so we know, is this doing what it's supposed to do? Sometimes we don't think that a color could be important. Not everybody thinks about the fact that yes, there are people that are colorblind, and if we set up a form or an interface for the user that has specific colors, some people will not see things the same as the rest of the population or the rest of the users. So we need to have familiar images, easy to understand. They're not offensive. Have on-screen instructions that are logical, clear, concise. They make sense. Everything should be there in a menu as well as having that graphical user interface. What we're doing should increase productivity. That's one of our in-game goals. Make things more efficient and make our users more effective in what they do. Now, if they give us the feedback we need, we're able to give them feedback and help them and enhance their productivity. Now, we need a layout that's attractive, easy to use, and has a good flow. So here's an example of a data entry interface. And at a glance, everybody that's using it should understand what it's doing and what's expected of them and how to interact with them. We'll have buttons, and you see here it says Find Student. That's a button. Print Record is a button. Help is a button. The text that exists on those buttons, the size of those buttons, any additional information like a label to the right of it that says, please remind students that tuition and fees are due by the first day of class, that helps the user interact with the system. Okay. Now we don't want to put too much, let me back up, we don't want to put too much on any given form, and we call this a form. We could have breakout or pop-out forms that come up in their own little interface, and that's what we see down below. If you click Find Student, that's a separate, distinct form that's initialized or triggered when you click that button. So that functionality may not be required for everybody. And understanding the system as a whole helps us develop these interfaces better. Okay. Now, there's something that we call input masking. We see it happen all too often, and that if I have to enter a phone number, they'll tell us, here's how we want you to enter it. And as it's being entered, it gets converted into another format. They say enter 3 digits, 4 digits. And then when we look at it, it's wrapped up in parentheses and it's got the dash in there. And the same thing with our social security number. That's what we call an input mask. We've got special characters that can pop up to give us help in some ways. We want to make sure that what the user inputs is validated. So there are checks that we can put into place to make sure that the data is valid. And we'll call them validation rules or data validation rules. We can do a sequence check that things happen in the order they're supposed to happen. Does data exist where it's supposed to exist when it's mandatory? Is it of the right type? Is it of the right range? Let's say that, please enter your age. And somebody enters in 312. I'm sorry, you're not 312 years old. Oops, my bad, I'm only 31. So it was a slight typo. But we need to make sure that those things exist. All too often, systems that you interact with, you'll be asked to confirm your entry. And the reason behind that is so we don't get bad data in the system. We don't want to collect bad data. Check to see if something is reasonable, valid, do a combination check, and there are batch controls, totals used to verify batch input. Okay. Now these are comparison operators to check to see tests on different values. All right. We've got more here. Try to cut down on how much is input, collect the most we can at one time. And we've got a concept that's called garbage in and garbage out. Our data is only as reliable as the people that input it and what they input. If somebody inputs garbage, that's what the system's going to produce. Okay. So, okay. Now, got technology issues when it comes to output. Now we've got different kinds of output. We've got screen output and printed output. They can be delivered in many ways. We've leaned more in recent years towards an internet or network-based, web-based delivery of information or data. Now there's pluses and minuses or drawbacks associated with that type of topology or outputting of data. Okay. Now, we could potentially have security issues when it comes to how things are being output. One of the things people don't take into account is if something's displayed on a screen, if there's no filter on that screen to prevent somebody from looking at that from say 40 feet from your left back behind you, we could put a filter on that screen that limits the user to be the only one looking at that data on a screen. So you have to be looking directly at it. You can't look at it diagonally. You can't look at it from above or below. You have to look at it directly. And it's filtered in a way that it becomes more difficult to see the further you are away from it. So we've got these ways to shield the data, protect the data so that people can't see it. If we printed it out, there's security issues with things that are printed, how we archive them, where we store them, how we transmit them, move them from place to place. Yeah, we hear every time you turn around, you hear about some medical records have been compromised because we found all these old medical records found in a dumpster behind a doctor's office. Who had access to them once they were thrown out? What data was in there? Was it sensitive? Was it important? It's very expensive to dispose of archived paper that holds data or information. But depending on the industry you're in, it could be legally required that you destroy things in a particular manner. Okay, so at this point, we can start prototyping our solution, our system, because we've done the analysis, we've planned, we've done the analysis, we've started designing. Now let's come up with some kind of prototype to see, is this it? Will this work for us? Okay, there's benefits to it, so we can see, is everything work the way we thought it would work? There's potential problems in that we've got more time. They may want to adopt the prototype and not get the full solution for whatever reason. And sometimes they jump the gun and say, we're going to go with that. And sorry, this is just a prototype, not the end game result. So when it comes to system design, we want to create a physical model of the system that satisfies the design requirements that were defined during the system analysis phase. Come up with a user interface, come up with the reports, and documentation. Okay. So we'll see you in the next chapter.